Hello student of class 10, let's continue our chapter Human Eye and the Colorful World. And today we are going to discuss few question answer. Our first question is, why is the clear sky color always blue? Student, we know in our earth there is atmosphere. In atmosphere many kinds of molecules present, like oxygen molecule, nitrogen molecule, and this kind of molecule size is compared to the wavelength of the different component size is always small. So therefore we can see the scattering of the light rays in differently for different color component. Student, remember, since the molecule of air are the smaller particles compared to the wavelength of visible light, so scattering will be take place here, and scattering will be according to their wavelength or frequency. Since blue color have the highest frequency compared to the red color, and red color wavelength is longer, that is why its frequency is less compared to the blue color. The red light has a wavelength about 1.8 times greater than the blue light. Thus, when sunlight passes through the atmosphere, the fine particles of air like oxygen molecule and nitrogen molecule, the blue color, that means which consists the shorter wavelength, will more strongly scatter compared to the red. The scattered blue light enter our eyes. If the earth had no atmosphere, there would not have been any scattering. Then the sky have looked dark. The sky appears dark to passenger flying at very high altitude, as scattering is not permanent at such height. So student, we found the answer why the sky color is blue. Since when light entered in our atmosphere, then in atmosphere many kinds of particles are present. In that particles, whenever the sunlight fall, the sunlight will be scattered according to their wavelength. So shorter wavelength will scatter more, means blue light will scatter more, and the red light will scatter less. As a result, we can see everywhere in our sky the blue light component, and we appear our sky is blue. But if we observe the sky from other planet, since other do not have the atmosphere, so scattering is not possible, and we will see the sky is a dark color. Hello students, let's continue another topic, atmospheric refraction. Already I have discussed with you. Atmospheric refraction is the refraction takes place in our atmosphere. In our atmosphere, every layer have a different density of air. So in our atmosphere, in each layer there is a different refractive index. So you might have observed the apparent random wavering or flickering of object seen through a turbulent stream of hot air rising above a fire or a radiator. The air just above the fire becomes hotter than the air further up. The hotter air is lighter, that is why we can say it is less dense, and the cooler air above, which is heavy, so which we can say it is a more dense, and the refractive index also slightly less than that of cooler air. Since the physical condition of the refracting medium are not stationary, the apparent position of the object as seen through the hot air fluctuate. This wavering is thus an effect of atmospheric refraction on a small scale in our local environment. Many phenomena like twinkling of star and delayed of sunlight sunset, all phenomena takes place because of the atmospheric refraction. So another time I am going to say what is atmospheric reflection. In our atmosphere there is different layer of air is present. In each layer the air pressure, air density is different. Hot air density always less compared to the cool air. So that is why whenever the light rays enter in our atmosphere, in each layer the light rays refract continuously and the refractive index also keep on changing. As a result, light rays will continuously refract and will come to the observer eyes in a bend way. And whenever the observer will observe the object, then the observer will see the object in a straight path, and that is why the actual location of the object is not easy from our earth in celestial case.